Yeah, good evening, all. Thank you so much for joining on time. It's yet another free masterclass or a free webinar on ETAP. Today, we are going to talk. I guess like some of you might have seen the single line diagram, but like I'm going to pick up the single line diagram and I'm going to talk about the same single line diagram for the next 60 to 75 minutes. If you're super excited for the session, just put SE, super excited for the session, SE in chat, and we'll get started. If you're super excited, cool. That's the energy which always I love to have. Cool. It's great. And before jumping into the topic, Sally, understand the background of the audience. Like, I mean to say, are you a student or are you working in academics or you are into design engineering or are you into operation maintenance or are you into testing and commissioning or are you into project management? Can you just put up like me to see what's your how you can define yourself so that like I mean to say that gives a clarity for me. All right, Aman from ONM, Balaji from maintenance, Asik Ali student, Dinesh Kumar student, Kunjan design, Sachin Pandey project engineer, Gulam Ali testing and commissioning, Tejas operation and maintenance, Rion planning design protection engineer, Roshni Patel student, MEP operation maintenance Mirina Mulhak, Sridhar design engineering, Rahul student, Arun TNC manager now shifted to design. That's great to hear. Roshan project, Samson operation maintenance, Karthik project management, Saran Hansaka O&M, Sakti Priya student. Yeah, I guess like chats are flying, so I didn't probably read everybody's. Rajesh design engineer, Leona testing and commissioning, protection engineer, Chauhan working as electrical engineer in TCE, Uttam Kumar, great to hear. Execution engineer Kausik, Dr. K. Paki Lakshmi student. Yep. After finishing PhD, calling yourself as student, great to hear. New products, GE Vernova, thank you so much. Sony, probably like, is it your name or is it your laptop? All right, I guess like there are quite a lot of chats which I have missed, but like we will try to cover everything. Maybe one last question which I want to ask. Uh, if you have experience, just put how many years, that number, experience in years. If you're a student or if you're not having experience, put zero in chat. Like, say, example, if you have 3 years experience, put three in chat. If you have 5.5 years experience, just put 5.5 in chat. If you're a student or if you do not have any experience, just put zero in chat. So that defines, like, I mean, to say how I have to properly handle it. Okay, I'm not a PhD holder. All right, no worries, Pakilashmi. Absolutely fine. Satish shot 10, Arun 16 plus, Tejas V16, Uttam 2.5, Liana 12, Aman 5, Asikali 0, student obvious, Ajo 3 years, Kunjan 11, Kudos Maiti 3, Rian 4, Rahul 0, Tejas 10 years, Srihari 3 years, 1 year in design, Sachin 9 years, HP 7, Hasanka 8 years, Adol 17, Banupriya 0, Engineer Floris 0, Sampunu 0 experience, Omakom Samson 1, Saktipriya 0. I'm not sure like how to pronounce that name. Toka something 7 years. Subhas 15, Dinesh 0, Nikul 5, Mir Inam Ulkag 8, Syed 10, Balaji 8, 16 years, 5 years in project management, Karthik 6.5 years, Venkatesh, Isam Muhammad 0, Rajesh Kumar 15, 0 experience, but finally electrical students. That's great sample. 10 years Alabi Sivam, 4 years Vinod, 5 years. I guess like it's giving some some good experience. 4 years design MEP zero in power sectors in the HSC field, 6 months in project management, 25 years. Like, I got like the variety of audience. I have promised, uh, like I mean, so say that as a last question. Otherwise, I would have asked one more question. Like I mean, so say, let me break my uh, promise and ask one last question. Which city and which country you are joining from? Which city and which country you are joining from? Which city? I know I'm breaking my promise. I have missed it anyway. Thank you so much. Sivam from Vadodara, Kiran from Ahmedabad, Visak, Colombo, Bengaluru, Bhubaneswar, Nigeria, Kerala, Vellore, Kuntur, United States, Nagpur, Tanzania, Mumbai, Algiers, Vadodara, Algeria, Morocco, Nepal, Morocco, Delhi, Hyderabad, Saudi, Jeddah, Saudi, Philippines, Jubail, KSA. I came to Jubail, Venkatesh, probably about 2, 3 months back. Coming Chennai, London, UK, Saudi Arabia, Riyadh, Surat, Saudi, Jammu, Vaisa, Kanchipuram, TN, Riyadh, Jugaut, Lagos, Nigeria, Coimbatore. Thank you so much, Dinesh, joining from Coimbatore. Delhi, Kanku, Bhopal, Madhya Pradesh, London, UK, Kazakhstan, Coimbatore. Yep, I'm seeing like second student from Coimbatore. That's great to see. Arnachalam, Kuwait, Rajasthan. Suri Prakash, third student from Coimbatore. That's great to see. All right. Which means like, I mean, so see, we are enhancing our local presence. Yep, that's great. All right. Let's get into the topic straight away with one of the slides. Let me keep that it open as well so that like I'm probably picking up from somewhere. All right. So let me pick it up. One of the single line diagram, which is drawn in other simulation software. Of course, like I have marked with something here and there. Let's leave it and probably like try to do that. And like means to say we have an ETAP single line diagram for that as well. And we will try to develop the same in ETAP today. And like we will try to do like I mean to say as max as possible. And yes, I hope my screen is visible, right? Like if my visibles like some single line diagram and ETAP single line diagram, like if both the single line diagrams are visible, just put V in chat. I'm facing some challenges from my side, like I'm just reconfirming whether it is visible. All right, that's visible. Then here we go. So single line diagram is visible. Something which we have done in ETAP is also visible. Today's topic is mastering ETAP. Probably let's try to do the single line diagram. And like I mean, so say, let's try to evaluate as max as possible and understand and align ourselves so that like we kept everything. So whatever the marks which I have taken, like I will probably remove this and then here we go. Yes. Let me check ETAP is visible. Yes. Let me create a new project as well. So let me open a Word file too. All right. Now let me jump into my recording as well so that like means to see if anything Manoj has missed out, like that will be captured from my side. Yep. Yes. So we have an empty word file which we will fill it along the go. We have ETAP single line diagram which has been drawn from the single line diagram which is available in some other simulation software. So here what you are seeing, let's understand the system. Let's understand the system. The system has like 220 kV bus. There's 220 kV substation. From 220 kV substation, there is two numbers of 100 MVA transformers stepping down to 110 kV. The transformers are operating in parallel. There is a 12-kilometer overhead line, ACSR Panther conductor, single circuit transmission line is there, which is connecting to another 110 kV substation where there is a loads, which essentially mean there is 110 bar 33 kV, 110 bar 11 kV step down distribution transformers feeding a load. But like the load has been modeled as a lumped load with 17.29 megawatt. Of course, power factor is not given, which you need to make an assumption. From that substation, there is a double circuit ACSR links conductor to the substation where the substation is feeding the steel industry. So this has like main and transfer scheme of 110 kV and 110 kV. There is 35 slash 40 MVA 110 bar 33 kV transformer, which is there stepping down from 110 kV to 33 kV. 33 kV side neutral is grounded via 19 ohm resistor, which is limiting single line to ground fault current to 1000 amps. And 33 kV, you have like means to say one incomer with the four outgoing feeders. First one, 4 megawatt rolling mill main drive. Second one, 20 MVA transformer stepping down from 33 kV to 0.63 kV. That is feeding electric arc furnace. Highly nonlinear, highly fluctuating load. And other one, 6 MVA transformer, 33 kV stepping down to 0.32 kV. Ladle refining furnace. And the fourth feeder is fifth harmonic filter bank. This may not be there at the stage of the beginning. You have to perform a harmonic analysis and then probably identify what's the rating of this filter. So, but at least like means to say, you have main drive. That name itself says it's a drive. So obviously there is a Powertronics variable frequency drive that injects a harmonics. Electric arc furnace, even a voltage source harmonics, which definitely injects a harmonics. Ladle refining furnace that also injects the harmonics. Then obviously when the point of interconnection, if the harmonics are not within the limit, you need to design a filter and the filter has been designed as well, which is presented here. And there is another 110 bar 11 kV 15 MVA transformer, 11 kV bus. There are many 11 bar 415 volt transformers, 1.25 MVA transformer 1, 1.25 MVA transformer 2, 3 MVA transformer 2, sorry, transformer 3 MVA first, 3 MVA second, 3 into 500 kVA transformer, and 11 bar 6.3 kV transformers stepping down from 11 kV to 6.9 kV, 315 kVA small transformer, 750 kilowatt oxygen plant direct online motor. There is another 500 kVA step down transformer and capacitor bank 5 MVA for power factor improvement. Since it is a steel industry, like I mean to say, there is a cogeneration as well. There is a 35 megawatt generator via 45 MVA step up transformer. A generator steps up to 110 kV and connect to the grid. If that's clear so far, just put CC in chat at least, even if you're not getting everything, but at least like a high level overview of the industry. Steel industry, which receives the power supply at 110 kV. So if you got something about this information about this industry, just put CC in chat. If you need any additional information, let me know your question in the chat. I will answer it. And then probably like we will start going to this Excel or probably that Word file and we will try to start fulfilling it. Thank you so much, Sony, for crystal clear. All right. When everything is clear, let me take a notes. It is steel industry, main loads are drive 4 megawatt, electric arc furnace EAF 20 MVA transformers, so approximately maybe 16 MVA load. Ladle refining furnace 6 MVA transformer, maybe 4.5 MVA load. These are all probably like means to say main loads which are connected at like means to say 33 kV, right? So when we talk about it's 33 kV, 26 plus 4, it is like 4 megawatt here, maybe 30, 31.5 MV, etc. So this 33 kV is fed by 110 bar 33 kV 35 slash 40 MVA transformer. This is the load. So this is highly nonlinear load. There is a filter which has been proposed as well, right? That's the fifth order. That's probably like what SLD indicates, but like you have to perform harmonic analysis to uh, like I mean to say understand. Like it means to say if you look at like means to say next one 11 kV, there is 110 bar 11 kV 15 MVA transformer. From 15 MVA, like here you have like multiple loads, 2 into 1250 kVA transformer, 2 into 3000 kVA transformer, 3 into 500 kVA transformer, then 1 into 315 kVA transformer, and 1 into 500 kVA transformer. These are all like means to say 11 bar 0.433 kV like step down transformers. There is another transformer which is stepping down from 11 kV to 6.9 kV or 6.6 kV. That is a 6.3 MVA transformer. So let me check my memory is right or not. Like means to say 11 bar 415 volt. How many transformers which are here? Two numbers of 1250 kVA. That's right. Two numbers of 3 MVA, which is right. Three numbers of 500 kVA, which is right. 6.3 MVA, 11 that 11 bar 6.9 kV, that is right. 315 kVA, that is perfect. 500 kVA, which is perfect. What I have missed is a 750 kilowatt DOL motor, which I have missed it, and a capacitor bank of 5 MVR, like means to say, for power factor improvement is what I have missed it. So I have probably made a note of it. If you think like I have memorized this data, answer is no. This is the project which I have done 20 years back when I have started as a power system engineer. And like means to say, I have taken this as a reference at least in 200 of my sessions. And that's the real reason why like I still remember this. I have not mugged it up, but like I mean to say, since I have probably like used it again and again, again and again, and then as an example, like I mean to say, uh, so I am remembering things. So if you want to become an expert in power systems, it is quite easy. Learn something, start teaching. You will make mistakes. You will correct it over the period. Fail fast, fail better. You will become an expert shortly. And if that is making sense, just type MS in chat. Yeah, it's not technical, but if you want to grow quickly in power systems, the way which you have to grow is you have to learn and you have to teach to others. If you teach, you will grow fast. All right, I guess like that's making sense for many. Cool. And like 135 megawatt captive power plant, it's a steam turbine. So 110 kV is main and transfer bus. So which has three outgoing feeders, two incoming transmission lines. What are the outgoing feeders? One is this 33 bar, sorry, 110 bar 33 kV 35/40 MVA transformer. Other one is 110 bar 11 kV 15 MVA transformer. The third one is 35 megawatt CPP, which is having another 45 MVA 110 bar 11 kV transformer. It might be a step up transformer, right? And it has two incoming lines. Both are like 3 kilometers overhead lines. And this overhead line is coming from another substation where like about 17.29 megawatt load is connected. And other like means the line is about like 12 kilometer and like means to say two numbers of 100 MVA transformer. So this is an industry. So like means see, like if you talk about a power system, if you are talking about a power system, like if you're talking about a power system, you have generation G, you have a transmission like T, you have a distribution which is D, and if you want, you can add utilization U. So, do we have a generation in this SLD? Answer is yes, we have a generation. Do we have a transmission? Yes, we have a transmission at 10 kV. So, definitely it's a transmission. Whether we have a distribution, answer is yes, of course. Like we have step down and like we have all these distributions. Whether you have utilization, answer is yes, we are utilizing and converting into like means to say motor, we are converting into mechanical energy, electric arc furnace, we are converting into heat, motor drive, like we are running some motors again. So it's a typical example of a project which has a generation in it, which has a transmission in it, which has a distribution in it, which has a utilization also in it. Why this first example, like 20 years back, which I have done this project, but why I'm probably using the same example because this is the best example, which probably helps. Because if you talk about a power system studies, you need to perform load flow, you need to perform short circuit, you need to perform motor acceleration, you need to perform transient stability, you need to perform relay coordination, you need to perform an arc flash study, you need to perform harmonic analysis, you need to perform grid islanding and load setting, you have to perform an earthing. This is a simple project which has an application of all. You take this project, you need to perform a load flow analysis. Why do you need to perform a load flow analysis? To find out the capacitor bank rating. To check what's the generator terminal voltage which you have to check. Like you need to check like whether OLTC is needed or de-energized tap changes are enough. If OLTC is needed, what is the minimum tap and what is the maximum tap which we need to set? What's the power factor at the point of interconnection? Whether the equipment loadings are within the limit or not. What's the total losses in the system? What's the best possible configurations? If the grid fails, how the system operates? With the grid, like means how this generator is sharing real and reactive power and maintaining power factor at the point of interconnections. This all has to be captured in load flow analysis. I know I'm little fast, but like if I'm looking at load flow, in order to find out a voltage profile at all buses, to find out equipment loading in all branches, to find out losses in each branch and total losses, when I mean like both real and reactive power losses, to decide whether OLTC is needed or de-energized tap changer is enough. If it is OLTC, like means in order to identify the range of the OLTC, to find out the power factor corrections, capacitor banks or a reactive power compensation to maintain the power factor at the point of interconnection, to decide what's the generated terminal set point voltage which we need to use, whether it's 100% or 101% or 102% and why. What's the optimal configuration Without grid, like means to say n minus 1 contingency, like when the grid fails, like means to say how the system behaves and how the system operates, like how the generator to be scheduled so that, like means to say, that's optimal. So like you need to answer like n number of questions. These are all the questions which you can address only from load flow analysis. If you, like means say, what's the short circuit withstand capability which is needed for all equipments at 33 kV, 11 kV, 6.6 kV, and 415 volt? What is the braking capability, making capability, and the DC interrupting capabilities of all breakers? Right? Braking, making, DC interrupting capabilities of all breakers. And like means to say, to check like over voltage during short circuit. Yes, I meant over voltage. During single line to ground fault at 33 kV, what's the rise in voltage? During single line to ground fault at 11 kV, what's the rise in voltage in the healthy phase when there is a single line to ground fault? To identify all this, you need to probably do a short circuit. To check the 750 kilowatt motor is able to start or not in direct online, which you need to perform motor starting study. If there is a fault in 220 kV or 110 kV or 33 kV, whether the generator remains in synchronism with the grid or not, within how much time the fault has to be cleared so that this generator remains in synchronism with the grid. This are all something like which you need to look at. This is basically called critical clearing time. So you need to find out a critical clearing time that's to be done from a transient stability. And protection coordination, of course, isolate the fault as soon as possible is an objective. Whether I'm clearing the fault well within the critical clearing time, whether I'm isolating the fault within the short circuit capability of an equipments, whether I'm able to isolate the fault, whether I'm sensitive enough, is there any mal operations? You need to do relay coordination. If I am doing on load maintenance or a live maintenance, you call, if you're doing a live maintenance, like you need to ensure that, like means to say, personal safety, which essentially come from, like means to say, PPE, personal protective equipments, which you need to wear. So you need to perform an R flash study. Since you have like so many nonlinear loads, how do you design your filter? You need harmonic analysis. If for suddenly if the grid fails, or probably like if there is a fault here, probably this breaker and this breaker will open. Like how the system probably comes to the standalone mode and probably like feed the loads which is needed. And like means if the generator is not capable of feeding the loads, how this load setting to be done to maintain the voltage and frequency constant. And like when this generator AVR has to move from maybe MVR control mode or a power factor control mode to voltage control mode, and like when it has to move from droop mode to like isochronous mode, which is like means to say constant frequency mode, all these things has to come from grid islanding, and of course earthing, step touch potential, etc. So why this project? Answer is quite simple. This project is example it is taken. This project involves like all power system studies which is actually needed to identify and optimize this project. If so far so clear, just put CC in chat. So far so clear, just put CC in chat. can we have this documents? I am giving you two choices. I am giving you I am giving you two choices. Choice number one, choice number one, you can probably pick it up the base level course if you're a student or less than like it means was a 1 or 2 year experience. Manoj, can we put up the both the links for like ETAP for beginners as well as our wake up call link? So like means to say there are two options through which you can probably pick it up the complete materials to understand bit more deep. So like what I am touching here today is a basic version of like means to say what's the statement and the problem statements. If you want to understand in deep, so you have two options. If you're a beginner, you can probably pick it up a beginner's course. And if you're probably looking at whatever the things which I am talking about, so you can probably pick it up the next level course. Manoj has shared the first link, that is ETAP software for beginners. You can probably pick it up this course. That's course number one. This is only for a beginners. I'm repeating it. It's only for a beginners. So SLD, load flow, short circuit, relay coordination, arc flash, and more. Right? This course consists of let us better understand single line diagram course, which every new year we will do. Load flow analysis using ETAP, short circuit analysis using ETAP, relay coordination using ETAP, R plus using ETAP, the back to basics, which connects the college theory to like means to say real time industrial exposure with some understanding on the simulations. So this is I'm saying it's for a beginners. It's for a beginners. It's not a live session. It is only a recording session. Only let us better understand single line diagram every year. Like January 1st, we will do a live session. So I guess like means to say if you add all these courses, like it will come like 5,000 or 6,500. And like means to say with a coupon code like what Manoj has said, you will be able to get it at 2,500. But it's only for a beginners. It's only for a recording. There is no live sessions. There is no Q&A. It's only the recording sessions of like means to say load flows, short circuit, relay coordination, R plus, back to basics. Let us better understand single line diagram. Let us better understand single line diagram. You will get like means live sessions every January 1st. And probably like previous year recording also you will get it. That's probably level one course. If you feel little advanced, if you feel little advanced, it's a bit crazy. We have something called like I mean say wake up call, crack ETAP before the sunrise every Sunday at 5:30 a.m. So initially we have started Thursday and Sunday, then probably like means to say because of my unavailability, like means to say we have probably eliminated this Thursday. It is only Sunday. It's probably like now it is not 5:30 to 6:30. It is going from 5:30 to 7:30 or 8, right? Uh, which we have started in like means to say October. 3 months up. Every Sunday we had, even today we had, and like means to say, uh, like the course cost was 10,000, and today you will get it at offer at 5,000 rupees. There are already like means to say 15, 16 classes are over, which means like about 30 hours, 30 hours of class is over. Uh, but like means to say, we have 3 more months, Jan, Feb, March, every Sunday at 5:30. You will have a live where you can probably ask questions with me directly, or probably like means in case if you're not able to join, you will be able to get recording. But this is a bit advanced course. What I mean by that, this is the first one is only the recording. Here, it's a recording, it's a live, it's an assignments. You have to solve this and probably like means say come back. So that's pretty much on the second one. And probably let's like go little more to this second one. And what's the outcome of the second one is what we are going to try it in next 30 minutes or so, I'm creating a new projects. Like means to say, what I am doing now in next 30 minutes, if you go through this course of the like I mean to say wake up call sessions, you will be able to do that probably 6 months down the line or 9 months down the line, what I'm doing in next 30 minutes. So I'm just putting ETAP wake up call itself. So let's get jump into this. So what I have done, I'm probably trying to put up this projects very quickly in a single line diagram format because I have this single line diagram. I have done sometimes back this in ETAP, and I have probably made a notes, and probably like let's check like how much time it takes for us to like I mean to say uh, like do this project. Project standard, like means say the project is in India, so like means say it's IEC ANSI, so I need to put IEC standard. Frequency is 50 hertz. Unit system, I am following metric. So if you are starting any projects, this is an important standard frequency unit systems. This is important. So project standards is where you have to start with. I am putting like project informations. I am putting project title as like wake up call. Location I am putting like means to say Coimbatore. I am just putting like means to say 1 2 3 4 5 6 is a contract name. I am writing my own number, sorry, name as engineer name, and I'm putting my company as a company here. Remarks, wake up call, free masterclass. That's the remarks which I have given. And let's get started with the projects. So I have enabled the auto builder option. I am selecting the list of voltages which are possible. So what's the voltage available in this project? I know it is 220 kV, which is 110 kV, which is 33 kV, 11 kV, 6.6 kV, and 0.415, like all the voltages which I have picked up. 220 kV, 110 kV, 33 kV, 11 kV, 6.6 kV, 415 volt. These are all the voltages which are available in the project. I am probably like I mean to say done with first option, and then like means to say I'm just starting my first equipment. So first equipment is grid, which is at 220 kV, and like means to say I need to probably set this voltage to 220 kV. So project has like 220, 110, 33, 11, 6.6 and 415. It is 220 kV. Grid short circuit MVA is what I need to enter. Of course, it is 4890 MVA. I am giving 4890 MVA with X by R of 14. And let's go ahead with another informations like me say transformer. It is 100 MVA transformer stepping down to 110 kV. There is an overhead line of 12 km, 110 kV bus. There is a 17.28 megawatt lump load which is connected. There is another 3 km overhead line double circuit which is connected, and it is 110 kV like main bus. To an extent, I am done with my model of up to this industry. It is 220 bar 110 kV, 100 MVA transformer. I'm checking the impedance, typical impedance I am giving, and probably validating the impedance. Here the impedance is only 10% I have given. Typical it is giving like 12.5. So I'm changing it to 10. So there are two transformers in parallel. So I'm probably like means to say just copy and pasting this second transformer as well, which means now model here is done. So it is 12 km line, 12 km line. So I need to enter the transmission line parameters of that particular conductor. So if I have a conductor data, I can directly enter the RX values. If not, I can probably follow the configuration of what's the configuration which is available. Both the options works. So I'm trying maybe the second option. I have given the transmission line conductor parameters, transmission tower configurations. Automatically, the software has calculated the resistance, and probably it's a single circuit. 17.28 megawatt is what we have seen. So 17.28 megawatt, and like power factor, like I have assumed 0.96, the load which I have done, and probably like this is a double circuit line. It is a 3 kilometer line. So again, I have to probably select the conductor parameter, and like I need to put up a configuration of this conductor. The software has automatically calculated the like line parameters, and like if I need to probably do a double circuit, I am I am done with the double circuit line. And like probably like means to say up to this ETAP SLD where it is probably drawn here, it is drawn in the horizontal format. If you want to rotate everything, you can probably like means to say rotate like means to say minus 90 degree. So I guess like means to say whatever you have modeled, whatever things there like means to say that will probably like means to say appear here. Only thing like this bus probably like means to say they kept it at like means horizontal, so which you can probably rotate it again, you will get it. So this load is leaking towards left, which you can model it. If you want, like means to say you can slightly extend it for beautification. And if you want, like means to say this bus data, like means to say transformer one, transformer two, all this data which you can probably like means selling. It is bus three here. All right, like this is main bus bar, and like this line details also done. So like it's not really taking much of our time, and probably like if you want to display all the parameters of the transformers, transmission lines, you can probably display whatever the informations which you want to display. So we have displayed the transmission line parameters, we have displayed the transformer parameters. So what are the parameters which you want? Like you can probably like display it. And if you still want to move this towards right little, you are probably able to easily move it. And yes, if you want to move a little further, that alignment also which you can pretty much do. Yes. And like I mean to say, whether you will be able to add like further, yes, you will be. So it is 110 bar 33 kV. Like I mean to say, you have pretty much like the transformer which you have added, and probably like means to say if you want to add a cable, you can add like means to say main bus bar. If you want to add like you can add like means to say further you can probably put up a like variable frequency drive or a main drive of like 4 megawatt. 33 kV definitely like means to say it is not the like means to say motor. It's a lump load. It is considered like means to say I'm just putting same thing like means to say 4 megawatt, maybe 3 MVR, like variable frequency drive, which probably like we are done with. So this transformer rating is now available. This transformer rating is 35/40 MVA, oil natural, air natural, oil natural, air forced. So and impedance is 10%. That information is also done. Grounding, it is star resistance grounded, limiting the current to 1000 amps. That is also done. So, like first feeder, lump load, which is done. Up to this, we are done. And probably like means to say here, like we have to put like electric arc furnace and ladle refining furnace. That's pretty much of the other loads. So here, like we need to add the size of the cables. 3 core 300 square cable for a 500 meter. 500 meter. 3 core 300 square cable. Like voltage rating is 33 kV. That's clear. So it is 3 core XLPE 300 square cable done. And like means to say here it is 3 runs, 3 core 400 square cable. It is 3 core 400 square cable. 33 kV is the voltage. 3 core 400 square cable. 3 runs, 100 meters. And it is 2 run 3 core 300, single run 3 core 300. So like which means like I can probably display the cable type, length, all these parameters, right? I guess like cable import another parameter which I have not really displayed is type, sorry, size. Yeah. So lump load which I have put like it is main drive. Sorry, main drive. So I need to probably like means to say copy this with the 2 runs. I have to copy this with the 2 runs, and it is 33 bar 6.6 0.66 20 MVA transformer, 0.6 20 MVA transformer, 0.63 20 MVA transformer. Impedance, I'm going for a typical, and like means to say, I'm just of course connecting a bus to that. We are done with, we have to put of course a lump load for it. I have connected a lump load as well. I'm connecting about like 16 percentage, 80 percentage of this lump load for this. I'm done. So it is electric arc furnace. If I want to rename this, I can probably rename it as electric arc furnace, probably in the load as well as the bus. Similar fashion, I can probably like means to say copy this and paste it. Like it is only single run. It is 6 MVA, and it is maybe I can probably rewrite it as like 4.8 MVA or something. So whatever the loads which is drawn here, except a harmonic filter, I have modeled this. Then it is quite simple and straightforward. I have to come down to 110 kV, another transformer which is stepping down from 110 kV to 11 kV. So, and here the voltage is not 33 kV. Here the voltage is 11 kV. That's it. Like it's 11 kV. It is 15 MVA transformer, and impedance typical, grounding limiting single line to ground fault current to 600 amps, right? 10.5 ohms, and we are done with. And if you want to display the symbol, you can display the symbol. So what actually we are trying to do this, we are trying to build the single line diagram. We are trying to build the single line diagram. why we are building this single line diagram is an important question. So like how much time it took for us? It hardly took 10 minutes for us. And probably like if we go in the same speed, like means the remaining things, we will be able to finish it in another 20 minutes. I'm not really going to do that, but like means see, typically you will be able to do that. So if you want, like we can probably add like one more uh, device as well, which is generator. So here let's probably pick it up again 11 kV and force this 11 kV, and we are done. So how much is the transformer rating? Transformer rating is 45 MVA. Typical impedance I am giving. Grounding, star grounded delta. And like what's the capacity of generator? 35 megawatt. And I'm just running the load flow. Yes, I'm running the load flow and I'm getting some results. Here it is some power is flowing, voltage is 100%, like here voltage is 98 percentage, here voltage is 97.39 percentage, here the voltage is 97.26. Here I have not modeled any load, so like power is not flowing. So here it is 92.85, 92.84. Generator is there, but it is not generating power. So lump load, like coming to say everywhere, like power is to an extent power is flowing. Yep. If I want to display the units, I can display the units. So far, what I have done, I have not really behaved as a power system engineer. I have behaved as a tool operator. What I have done, I have done a task of a tool operator. What I have done, I have just probably like means to say copy pasted or just modeled what is there in this. I have never asked a question why it is, and I have never asked a question like means to say how it is to be modeled. I have never asked a question like means to say what is to be done, etc. etc. So I have just behaved as a tool operator. When you are sitting in ETAP and using it as an AutoCAD, you are not a power system engineer, you are a tool operator. If you want to become a tool operator, please do not become a tool operator in ETAP. Better become a tool operator in AutoCAD or MicroStation or probably ePlan, etc. etc. because they are presenting tools. ETAP is a power system analyzing tool. My statement might be a bit harsh. Let that goes and probably try to sync that. If you have decided to play the role of a tool operator, please do not become an ETAP tool operator. Better become an AutoCAD tool operator or probably like MicroStation tool operator. Don't become an ETAP tool operator. Like when you started using ETAP, ETAP is power system analysis tool. Power system analysis tool, which means what you need to do is you need to do analysis. You need to do analysis. You should not focus on probably like presenting something. So what I mean by that, you should have asked a question, why I am giving this short circuit MVA, why I am modeling this transmission line like this, why this vector group is star grounded, why it is delta, why this load is connected at like 33 kV, why this load cannot be connected at 11 kV, why this transformer impedance is this much, why it is resistance grounded, etc. etc. You have to ask thousands of thousand questions. And how do you model and probably like means to say all these questions like what you have written here, like that has to be get answered by studies, by simulations. So you're not just presenting it like it is tool is not intelligent. Of course, we are talking about an artificial intelligent in many aspects. Like means to say, ching boom ba, like means to say, ETAP, please run this analysis and probably give me the results or give me the optimized results. ETAP as such, like it is not that much like artificial intelligence. By just looking at the single line diagram, it will optimize and give you the recommendations. Software has not improved. And probably like Bill Gates recently quoted, like means what are the three domains or three sectors which will not have an impact by artificial intelligence? What he's told is one of this is ours, which is power system analysis or energy or renewable. That's what he had talked about. Like he has talked about like three jobs which will not have an impact because of artificial intelligence. One, obviously, it is a coding for an artificial intelligence. Second one is a biology, which your artificial intelligence cannot replace. third one which he has talked about is like I mean to say our electrical engineering more specific to renewables energy and probably like the power system analysis topic which we are discussing. So which means just not ETAP. None of the power system simulation softwares has probably like replaced the power system engineers. Right, like other places like we are talking about like means job cutting because of AI. So of course, AI is enhancing the way which you are probably like using the power system simulation softwares, but AI is not the replacement for a power system engineer. And like because it is quite complex, the end of the day, as such, what's the present AI which has doesn't have the capability to replace you. And if you become a tool operator in AutoCAD, your job may be lost because tomorrow there could be like I mean to say softwares they can probably integrate this like I mean to say all this options at least like a kind of a building block etc with the minimal inputs maybe by a text or probably by a speech the softwares will be able to develop a single line diagram for you. So if you have decided to play the game of tool operators, I am sorry, let me repeat my statement. If you have decided to play the role of tool operators, AI can replace your job. If you have decided to play the role of power system engineer, your job will not only grow exponentially, but also like means you will have a sense of satisfaction. Yes, I have designed and optimized the system. Then probably like means blindly saying my salary has increased, right? I guess like I mean so say so far if the session is useful, just put useful in chat. So far, the session is useful, but just put useful in chat. 57 minutes from the beginning. The session is useful, just put useful in chat. Why we ask always this? Because that's our marketing. Let me honest with you. Like means I used to say that like I mean so say uh, uh, power projects do not have a sales team. Power projects do not have a marketing team. Power projects do not have that these etc. Answer honestly yes. Power projects do not have a sales team. Power projects do not have a marketing team. All these things are true. But Power Projects has understood that educating the peoples is an amazing marketing. If you agree, type agree in chat. What I have done is marketing, right? I'm not denying it, but like means to say that's what it is value addition, which is viewed, which is a great marketing tool, which probably like most of the companies are not willing to, and that we have decided to use that marketing. And probably I'm educating to many of my our competitors that like means use education marketing, probably like they are not willing to do, right? There is a lot of in-depth required for understanding ETAP. Absolutely, absolutely. Don't operate with the tools in ETAP. This concept is outstanding. Thank you so much. Shall I take, shall I take, like means to say 5 minutes to explain what we offer as ETAP community with us. We will not sell an ETAP course. There is something called ETAP community. Means to say, shall I take 5 minutes? If yes, just put five in chat. Number five in chat, and I will probably take only 5 minutes of yours. All right. Thank you so much. So we are offering an ETAP lifetime membership. What I'm probably like means to say saying by lifetime membership rather than ETAP course. Manoj, can you just put up the brooch of it as well as the registration link for it? So like means to say we believe in lifelong learning. We believe in lifelong learning. And probably like means to say when you have studied in your LKG or a pre-KG, you might have learned ABC. Like means say when you're going to the next level standards, obviously like you're learning how to frame the words, how to frame the sentences. Probably subsequently you're learning how to write paragraphs, then how to write essays, and then probably like you're using this language probably for your career. And even now like means you're keep learning something new, right? We always believe in lifelong learnings. That's the reason why we are not selling. That's the reason why we are not selling courses. We are selling a community. This is a lifetime community. What I mean by like lifetime community is, let me open this ETAP brooch what Manoj has shared. So whether it has a course, yes, it has a course also, but it's just not a course. When others started chasing the courses, probably collecting the money from like training participants, we have probably decided to play a bigger game. This is an ETAP training course content where you have like means to say all the topics like what I have talked here, like load flow, short circuit, motor acceleration, transient, relay coordination, arc class, harmonics, all these things like we are covering. We are covering theory, we are covering mathematical equations, we are covering how that has to be modeled in ETAP, and like we are covering like small examples and assignments that will teach you like maybe words, sentences, maybe small paragraphs. Like further, like we are adding on, like I mean to say, 10 real-time case studies, at least 10 real-time projects. One such is like this. Because after writing one paragraph or one essay, you will never become an expert. You have to consistently like write like so many essays, so many paragraphs, right? Like so 10 real-time projects. Pause Projects is a power system consulting company. We have done projects in 55 different countries. And like means say in that like we handpick the right projects so that like we can probably empower the participants. Such like 10 real-time projects are available. 800 plus hours of recording sessions directly available from me. Lifetime WhatsApp community support which is available. And like I mean to say we have a course live sessions. This is Monday to Thursday. We have 10 to 4:30. Monday to Friday evening 7 to 9. Monday to Thursday, it is only like means to say physical classes. Please make a note. Like the first one is only physical classes in our Chennai office and Coimbatore office. So all other things are live. Monday to Friday, 7 to 9. Friday, it is for a Middle East batch. Saturday, Sunday, it is like for working peoples. Sunday for the peoples those who have 6 days a week. How much it will cost you? It's costing you 40,000 or $550. It's a lifetime community membership with 12 let us better understand courses like let us better understand generator, let us better understand transformer, motor, because like these are all like equipments has to go depth and probably understand. So let us better understand equipment courses. ETAP basics to advanced, like 25 different courses on this, 10 real-time courses, 2 other software courses, plus lifetime wake-up call on Sunday 5:30, right? Like if you have purchased like the earlier one, like what Manoj has said, that is going to be for only next 3 months. But like means to say, if you come to this community, it's a lifetime Sunday 5:30 a.m. for 2 hours, right? That's pretty much of it. It is a course schedule. Anyway, Manoj has said it. This is a live. And like means to say, if you're willing to grow and transform yourself to the next level, honestly, like this will transform you. Of course, you need to put an effort. I'm not saying this course will transform you. I will not say power projects will transform you. If you're willing to put an effort, this course and power projects provides a platform to transform you. I know people, those who came to this course, joined the course, practiced it, joined like means to say 5:30 a.m. wake up call sessions, practiced real time projects, and they have earned more money than what they have invested, like this $550 or 40,000, by means of doing a freelancing for power projects or just referring a projects by looking at our consulting strength, referring a projects to us and probably making referral bonuses. So I always believe in the biggest investment which you can do is not a real estate, not probably like I mean to say investment in shares, equities, mutual funds, but investing in self. If you're willing to invest, there is a link which Manoj has shared. So you can probably pick up this link. When is our next batches, which is all probably listed? WS Saturday Sunday batch starting on 10th Jan, which is coming Saturday. Physical batch, which is already started. So like next batch, you contact our team. Sunday special, like which is starting on 1st March. Like physical in our Coimbatore office, it's starting on 9th January after Pongal. Like evening batch, which is starting on 12th January, that is on upcoming Monday. Friday special, which has already started and which is running. If none of the course timing is fixed, then probably like you take like one-to-one custom design course, exclusively sit with a trainer, and you can pick up only the recordings. So just fill your email, and probably like you are not making a payment here because we want to understand whether you are an ideal fit for us, because we don't want to collect your money if we believe that like we will not be able to add a value. So filling the form, does it mean like means to say you are qualified? Our team will contact you, our team will check you. Only when we believe we can transform you, we will like means to say collect the money and we'll probably put it in the course. And I know I took like little more than 5 minutes what I have asked for, but I guess like that made you sense. And it's our responsibility to ensure that we are adding a 10x value than what's the money which we are collecting from. And honestly, we are adding 100x value for the lifetime. Probably if you look this value within probably like 3 months, 6 months, it is 1x. If you're looking 2 years, 3 years, it is 10x. Like if you're looking for a decade, damn sure, like it is 100x. That's pretty much from me. And like means we have a contact number of Priya, we have a contact number of Lavanya. So their LinkedIn profile is also there, and you can reach out to them. And I'm done. When I say I'm done, I'm done. Like if there is any questions, if it's probably like I mean to say, even if you're not purchasing the course, we still love you. Come for each and every free webinar which we are doing at 7 o'clock. I completely respect the decision of not buying. But one thing which is assured from our side, if you take the course, that platform what we have will transform you if you are willing to put an effort, right? It is not like one directional like a commitment, it's a bi-directional commitment. If you're willing to put an effort, this course will transform you. All right, I'm done. If there's any questions, I'm happy to take. EMI option will be available, Abhijit, you can talk it to. How can we get a certificate? Like I mean to say, can we pay in installments? Answer is yes. No, can we put up like an experience like this certificate for this free webinar, so that like means to say you can probably like I mean to say people can collect the certificate, and I have a small gift also. Collect the certificate, and there is a gift also. Don't worry about it. Manoj, we can probably put it the certificate link. So you can probably like means to say make a partial payment. Yes, you can get an EMI option. Yes, like means to say if you have any doubts or clarifications, talk to Priya, talk to Lavanya. Do not make the payment. That's what I always say. Don't make the payment till you completely satisfied with yourself, right? Ask thousand questions. If you get convinced, because you are investing money, it's your money, right? What I am talking about is my experience. Like, but like it is not necessary that like means you have to believe in the same way. You have all the rights to check with our team, discuss like means say understand like what's the process, how it goes, etc., etc. Then you make a payment. All right. So that's always like generally like we are not pushing people to buy it. We will check whether you are eligible. Only when we believe we will be able to transform you, we will collect the money from you. It's our promise. Like my team has been trained to do that. Okay, don't worry about it. So you will not lose the money. All right. So, like Manoj has said, a certificate. If you want, really, really, if you want a gift, I have a special gift for you. So that special gift will come. Like means say, fill your name, fill your mobile number, rate this webinar, write any feedback which you want, like what's next free webinar which you need, like how was the free webinar, what it is, etc., etc. Submit it. You will get the certificate. You will get the certificate. You will get the certificate in your mail. It's an automated mail. Let's probably like check it. I am putting it Selva Kumar. I'm putting it like means 1 2 3 4 5 6 7 8. Please give like means with the country code, like give right number so that like means in case if there is any email mismatch, our team can contact you. So rating of the webinar 4 out of 5, 1 being the worst, 5 being the best. I'm just giving 4. Any feedback? So next, means to say PSCAD, like which means like means to say conduct PSCAD free webinar on PSCAD. That's the feedback. Like I'm just giving it just an update. Of course, you have to give a record email, otherwise it will not allow you. And probably like means to say you have probably like Priya's contact number for business development training, Chit's contact number for business development projects, and like if you open your mail, it may land in spam, but the certificate will reach in probably seconds, not in minutes. Let's check like whether we have received the certificate or not. It's a last week certificate. I have tested in front of you. Yeah. Now it is not taking seconds, it is taking minutes, it seems. Let's see whether we are getting a certificate. Yes, probably like in front of your eyes, I have filled this and I got the certificate. So here is the certificate. So it will be named with Manoj. In case if it is not landing in case if it is not landing in inbox, it may land in spam or like means junk, etc., etc. Please check it. Still, if you're not getting the certificate, absolutely all right. Like means say, reach out to Manoj, like means say, he will ensure that like you are getting a certificate. And if you are not connected with me on LinkedIn, I have about 34,332 followers. We believe in adding values. Ensure that you are connected with me on LinkedIn as well. After collecting the certificate, come back to LinkedIn. Come back to LinkedIn. If you do not have an account created, come to LinkedIn, start a new post, write whatever the things which you have learned, add the certificate, add the certificate, ensure that you are tagging me, ensure that you are tagging Power Projects, ensure that you are tagging Manoj. Even if you miss to tag Selvakumar and Power Projects, ensure that you tag Manoj because he is the one who is going to share you the gift. Like we said, tag all the 3. If you forget first 2, no problem. But if you miss the third one, you will not get the gift. So ensure that you are tagging Manoj K. Sanmugam and like write in detail what is your key learnings in today's sessions. Technical, managerial, marketing, whatever it is, write it. Technical is not the only thing which is learning. So like write it, probably hit a post, and probably like means when Manoj gets notified, Manoj will share you the gift in the LinkedIn chat itself. In case if he is not, reach out to him in LinkedIn itself. And that's pretty much from me. And thanks for all those who are giving a friend request. So like I probably like accept it probably in a couple of minutes after the sessions. All right, I am done. Hope the last 75 minutes was useful in your life. I always say this, the biggest gift which you can give it to others in your life is your time. Thank you for trusting us. Thank you for trusting me. Thank you for trusting Power Projects. Sunday, 7 p.m. to 8:15 p.m. India time, you could have done quite a lot of things with your family, friends, relatives, movie. You have decided to spend this time with us, and we are super proud. And we would be love to have you on all the upcoming weeks because we have a free webinar every Sunday at 7 p.m. If you feel like you got some value, ensure that like means to say whatever the topic which you are interested in, come every 7 p.m. When I say every 7 p.m., every Sunday 7 p.m. in the webinar. So next week we have selection on power system simulation software. 25th, we have grid complaint study using PSCAD. And like 18th, we are coming up with another amazing, interesting, like means a real-time projects case study. And again, like every first Sunday, like we do a free masterclass on ETAP. Career guidance, which we are doing, like means say if you are probably like means say testing and commissioning, operation maintenance, fresher, if you want to look for a job in power system, like how to get it, like means to say you can have it. PSSE, ETAP, Besson microgrids, transformers, like I mean, so see, we have probably a schedule and 52 Sundays we will be having 52 classes. Ensure that like means to say you are probably like means to say registering. All right, that's pretty much from me. Whether today's session is over, answer is yes. Thank you so much, Augustine, for receiving the certificate. Ensure that like you're posting it. All right, I'm done. Thank you all. Thank you so much. Have a great weekend. We'll catch you on next Sunday at 7 p.m. Yep. Thank you all. Thank you so much. Yep. Thank you all. Thank you so much.